Let's create a low-level design for the game Connect 4. First of all, if you're not familiar with the game itself, let's go over the background quickly. It's sort of like a board game that's played on a 6x7 grid. There are two players. Usually one player is color red and another player is color yellow. Let's say the yellow player goes first. Basically, the choice that they have is which column do they want to drop a piece in. So suppose they dropped a piece in this column. The piece would keep falling until it couldn't fall any further. In this case, since all of these cells are empty, the yellow piece would fall all the way to the bottom and it would be filled down here. Next, the red player would go, and similarly, they'd be able to choose a column. Let's say they picked the exact same column. In this case, the piece would keep falling until it can't go any further. It can't go past this one, so it would fill in right here. And each player keeps going until one of the players has 4 pieces connected in a row, for example, like this. That's why the game is called Connect 4. All you need to do is connect 4 pieces either horizontally or vertically, or maybe even diagonally. This is considered a regular diagonal, and this is considered like the opposite diagonal or the anti-diagonal, but basically 4 pieces connected in a row in any orientation, and then you win. So in this case, the yellow player would win. So how do we design a solution for this problem? Well, first of all, these are just the assumptions that we have made so far. I mean, this is what I know about the game Connect 4, but your interviewer might have a completely different idea in mind. It's very important that before you start forming your solution that you clarify the requirements with your interviewer. Some possible questions that we could ask are, what are the rules of Connect 4? The rules I stated might not be the same ones that your interviewer has in mind. Or what about the dimensions of the grid? Are we just using a standard 6x7 grid, or do we have a variable grid? Maybe we want to play Connect 4 on a 100x100 grid. Also, how many players do we have? Usually it's played with 2 players, but maybe we want to have 4 players or 10 players. Maybe it's a battle royale of Connect 4. Let's say for this problem, the rules are going to be pretty similar to what I said. We just need to connect 4 pieces horizontally, vertically, or diagonally. But in this case, the grid should be of variable length. So we could have an arbitrary number of rows and an arbitrary number of columns. But we are going to keep this as being a 2-player game. Also, let's say we want this to be player versus player, not a player playing against the computer or playing against an AI. Also, one variation, instead of connecting 4 pieces, we also want to be able to connect an arbitrary number of disks in a row. Basically, I'm saying that the rules could be flexible depending on what parameter we provide. We might be playing Connect 4, or we might be playing Connect 5 or 6. This is just adding a bit of flexibility to our design. We'll call that Connect N, whatever, N, I guess I already used N here, but you get the point that this is a variable. This itself, this 4 here, is a variable. And lastly, we want to keep track of the score. So 2 players are playing against each other. We want to keep track of the score, and we want to have a target score. When one of the players reaches this target score, they win. So if they win one round, their score increases. So among these 2 players, maybe red wins once, then their score is 1. Maybe yellow wins, then their score is 1. So it's tied 1-1. And maybe the target score is equal to 2. Then once the, let's say, red player reaches a target score of 2, they are the winner and the game is over then. So in that case, it would be best of 3, but the target score could be an arbitrary number. So the way I like to approach this is just to quickly go over the high level details of which kinds of classes we're going to have and how they're going to interact with each other. I don't want to spend too much time building like a super in-depth UML diagram. I think we can represent all the same information in code anyway, and I think that's better, but it's up to you. Sometimes in interviews, you have the flexibility. If you want to just do things with diagrams, you can. If you want to do things with code, I prefer it with code, but I think for a high level, it does make sense to kind of draw it out at first. So of course we know we're going to have a grid class. What is that grid going to do for us? It's going to represent the state of the board. So we can imagine we have like a 2-dimensional matrix, which for every position, we know the state of that position. A position could be either empty, it could be occupied by the red player, or it could be occupied by the yellow player. So a good way to represent these 3 states, in my opinion, is by using an enum, I don't know the best name to call it, but maybe grid position or grid position state, but I like to be concise, so grid position, though there's probably a better name for this. Maybe you can think of one yourself, but the grid will be a two-dimensional matrix of grid positions. Initially, it's going to be completely empty, of course. And the main thing we're going to be doing with this grid is placing pieces in it. Whether it's a red player or the yellow player, we want to be able to call place piece. That's what I'll call it, I guess. And what we're going to pass in is going to be which column do we want to put that piece in, as well as which player is the one that's making the move. For that, it's either going to be yellow or red, so that could be another parameter that we pass into our place piece method. It's a little bit strange because the piece is an enum, and it could be also that we pass in empty into it. So maybe we could add additional validation to ensure that the piece is either red or yellow. We're not passing empty when we call place piece. We could have designed this in such a way that the red and yellow are of a different type than the empty. Or maybe we could have just not created an enum and just not had empty in the first place. And then every position in the grid would be represented by null. That is an alternative. I think this is a bit cleaner, even if it's not perfect, but it's up to you. I think you do have some flexibility as long as you can kind of talk about it and discuss different options for doing the same thing. I think that's what I would be looking for if I was interviewing you. And we also are going to have a game class. This game class is going to be composed of a grid. We, of course, have to have a grid to play the game. And I'm also going to have a player class where we're going to have two players, and each player is going to be assigned either the red or yellow color. And then that is how we're going to be playing the game. And we're also going to be keeping track of how many rounds has the red player won and how many rounds has the yellow player won. That information can also be tracked in our game class. In terms of how we can break down this game class, we know that ultimately we want to be able to play the game. So that could be like the outermost method that does everything for us. But underneath the hood, when we play a game, we know that to play a game, we have to play rounds, because a game is made up of multiple rounds, but one round is made up of multiple moves. So this could be a loop that's running play move. And this play move will basically get input from the red player, then play that move, and get input from the yellow player and play that move until the round is over. And then the play method will update the score. We'll either play another round, or if we've reached the target score, the play method will basically complete. So now let's take a look at the code. So I'll start by just coding up some of the basic definitions, and then we'll look at the entire code more in depth. The first thing we know is we wanted to create an enum for the grid position. And I think in a real interview, you wouldn't need to be super precise with like your imports and all that. And you wouldn't necessarily need to fill in every single detail. So we know that we'll have a few states. One is empty. We'll represent this with integers because I think that will work perfectly fine. We don't need to do strings or anything super fancy. And then we have our grid, which is one of our most important classes. We know that it could be a variable dimension. So it's very important that we have parameters to control that. So the number of rows and the number of columns are going to be parameters that we set in the grid. This is part of the dependency inversion principle. Our grid should be flexible and its dependencies should be provided to it so that it can be of variable dimensions. Otherwise, when we initialize the grid, we would have to hard code that logic inside of this class and the dimensions as well. So I'll start by setting the grid to null. It will be a two-dimensional matrix, but we'll handle that logic of building it inside the init grid method. This is optional. You could initialize it in the constructor, but I think it's a little bit cleaner to do it like this. Also, we could have passed in the rows and columns into init grid, and maybe that would provide more flexibility if this is a public method, which would allow us to like change the dimensions of a grid at runtime. But I think that's not required for this. That would kind of get into over engineering, so I will avoid that. I filled out a few more methods. Init grid is basically creating an empty grid of empty positions, a two-dimensional grid with rows by columns dimensions. We have a getter for our grid. We can get the column count. This will be useful when we're playing the game. This will allow us to tell the user which columns are available for them to place a piece in. And then, of course, the place piece method. That's probably the most important part. That's one of the most important parts of the grid. We have some validation logic, but you wouldn't necessarily need to implement this in a real interview because coding this entire design out, which I'm going to show you, is not probably going to be feasible in a 30 or 45-minute interview. But I do think it's helpful to see how it's done. And the more you practice it, the more these kind of relationships and these method definitions will become second nature to you. But a couple of validators we could add is making sure the column is valid and also making sure that the piece provided to us is not the empty piece. This is necessary sort of because of a design flaw, almost you could say. Ideally, we would have a separate type for the red and yellow enums. But I think for a simple problem like this, that would just overcomplicate the solution. Also, we want to be able to check if a player has won yet. You could argue that this check win doesn't necessarily need to be a part of the grid. If we have a getter for the grid, maybe the game can implement this. And you'd be right. I think that might be another valid way to do this. Or maybe even we could rename this to is n connected, because the grid itself doesn't know that there's a game being played. But I think for readability, this is simple enough. In terms of implementation, I won't go super in depth, but we're checking if this many pieces of the same color are connected horizontally or connected vertically or connected diagonally or anti-diagonally. And if they are, we return true. If not, we return false. This will tell us if a player has won yet. We also provide a row, column, and piece because every time a player places a piece, we only need to check if that new piece that was added is part of a connect for or connect n. We don't necessarily need to check the entire grid. We just need to check every time a new piece is added. I also think it's helpful to have a player class just to encapsulate some information about the player. In this case, the most important and probably the only thing that we're using is the piece color for that player, whether it's red or yellow. But this does give us some flexibility if we wanted to extend some functionality. And we don't have too many classes anyway, so I think the addition of this doesn't overcomplicate our design too much. Now for the bulk of our design, we have our game class. We know that it's going to need a grid. You could argue that the grid could just be instantiated within the class, and I think that's a perfectly fine way to do it as well, though there's really no downside in my opinion to providing the grid as a parameter. Dependency injection is always a good thing. An alternative though would have been to, instead of providing the grid, we just provide the dimensions of that grid and the game class instantiates its own grid using those dimensions. The upside of this is maybe if we had different types of grids, we could pass those in as parameters, and the game could be played on those different grids. And each of those grids could implement a different way to check if there's a winner. So there is some possible flexibility in that case, but I think prioritizing that is over engineering. But it's not bad to like think about these things and talk about them and to just understand the pros and cons of the design that you're creating. Are we limiting ourselves in any way, or are we overcomplicating things? I think in this case, we reach a pretty decent balance. We also provide how many pieces need to be connected in a row. We also give the target score. Once that target score is reached, we know the game is over. We initialize 2 players. Here you can see we're actually creating the players. We're not providing them because we know that one player is going to be yellow and one player is going to be red. And we just call them player 1 and player 2. We initialize them with an array. There's no major upside in this case because there's only 2 players anyway, but there's no downside either. So I think it's fine to have an array. If we wanted to add like 4 players, it'd be a pretty easy way to do this just by adding to this list. And the way we initialize the scores for each player is just by setting it to 0. We have a helper method to print the grid. This probably wouldn't be required in an interview. I just think when running this code, it makes things a bit readable and easier to understand. The fact that this print board is in the game class though, and not in the grid class, I think does make sense. Usually a class is not responsible for printing itself, and the game itself can decide how we want to print the board. We know that the board state is represented with enums, but how do we actually want to print that enum? The game is what should be responsible for deciding it. Maybe we have a graphical user interface that we want to use instead. And maybe we could have even had the print board go in a separate class if we actually did have a graphical user interface. So that's kind of my reasoning behind that. We, of course, have a play move method, where we are reading a column from the user input and then making that move. And from this, we return what was the position that the piece landed at. So then within our play round method, after a move has been made, on those coordinates, we check, does that result in a win? If it does, we increment the score for that player and return that player. Otherwise, we just keep continuing until one of the players wins. Now, one implementation flaw here is that the game could possibly end in a draw, in which case we should probably return null. But the whole point of this code is not to have like a bug-free solution. It's just to kind of get the overall design. I could add additional validation in many places, but that would just make the code super long and hard to read. So we'll focus on the most important parts of this. Though I will say that this code does run, and if you want to test it and play the game itself, you can. If you want to make modifications or write your own variation, I definitely encourage you to do so. Lastly, we have our play method, which will basically call play round in a loop until the target score has been reached, and then it will print who won the game. A sample way to play this would be like this. We create a grid, we pass that grid into the game, and we play the game. Here you can see the connect n is 4, so we're playing connect 4. We could change this to 7, then we're playing connect 7. And we're setting the target score to be 2. So whoever wins 2 rounds first wins the game. So this is one way to solve this problem. I will say this is not the definitive solution. There's many different ways you can solve this problem. I think the most important thing though is everything you do, you should think about the trade-offs. What's the pros and cons of every class you're creating? Could things be done differently? Is it extensible, or maybe are we overcomplicating things? We could have had maybe several more classes to break this solution down. What would be the benefit of doing that? Maybe you could say that this check win method is super long. I would argue it's better to keep it in one place just for simplicity, but maybe you have a better solution. That's what it's about, just kind of justifying your thoughts. Engineers, even senior engineers, disagree on these types of things all the time. I've seen it many times. There's no definitive answer, and that's the important thing when it comes to object-oriented design.